what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you're new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside the show while it's live, and a PayPal link in the info box below the video once it's rendered. But most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using stock accounts. You'll be warmly welcome back on the next stream. Please also share the show. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you are new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by John, Ranty and Arwin. How are you all doing?
All doing good.
Good evening.
Good
afternoon.
Of course, yeah, it's different for you, isn't it? It's evening for us.
Yep.
Well, afternoon for you, John. Good afternoon.
Sun is still up here, though. It's summer.
Is it flat over there as well? John?
Yeah.
Yeah.
Mind if I do a little bit of housekeeping, gentlemen? So, any signs of axial rotation? Anyone?
No.
Nope.
Any
But
evidence
there
of
have
R
been
transpired?
some signs of apparent curvature change. So I've been working on this theory, a new approach to the globe Earth, that if the curvature is not consistent, then the Earth must be a wobbly mass, like a water balloon. What do you guys think?
It's got a lot of it on it, so don't see why not.
Wobbly balloon Earth, that's a new one.
Yeah. So with constantly changing curvature, it seems to be changing. So if we can
Optical.
see it, it must be there. Then, well, the Earth must be a wobbly mass.
All optical, my friend.
I know.
Talking about wobbling, is there any evidence out there for molten, self-perpetuating molten iron core? If I get my tongue around it. Any evidence of that transpired since we last spoke?
If it's a wobbly mass, then maybe it's a watery core. So maybe the Earth literally is a water balloon.
Take that as a no.
Negative.
Negative. No.
Pressurized
Don't know of
system
any
next to a
molten core.
non-pressurized system. Any signs of that? Anybody?
Non-pressurized system.
No. I think it's impossible to have a pressurized system next to a vacuum.
We're going to talk about that. That's a big negative.
I don't even know if a non-pressurized system could exist at all, really.
What, it's a complete vacuum?
Yeah.
You doubt a
Nature
vacuum?
abhors
That's
a vacuum.
interesting.
That means you'd have to have an endless open space somewhere. How can you even emulate that, except in theory?
Yeah, I'll go with you on that score, for sure.
It's like creating a vacuum world.
It's like the theory of gravity. The
Right.
theory of space. Everything is a theory. They have no facts. They have no proofs. Everything's a theory.
Indeed.
Scientific evidence of R?
No, definitely not seen any of that.
Nathan's the expert on that.
Well, I'm the expert on the lack of it.
Yeah.
Okay, right. There's a couple of presentations that I know you guys have got lined up in your back pockets. John, do you want to tell us about your reactions that you're going to do first? Is that what you planned on doing first?
Yeah, we can go into that first. You want to share my screen? You want to start now?
Yeah. Just lead us in by telling us, who you're reacting to and all that good
Yeah,
stuff.
I'm going to talk about it here in a second. Let me
Yeah,
know
you're
when
on.
this is up.
Yeah, you're on.
All right, yeah. The day before yesterday, I ran into a video, and it was this one right here. I just seen it out of the corner of my eye, and I noted Brian Mullen, and I haven't seen that name in a while. He hasn't been around in a while, and I said, huh, can't be having a video now. This must be an older one. So I went ahead and clicked on it, and this came up right here. So Brian Mullen, balls out failure part 1. And I said, boy, it's got to be old. And no, just a few weeks ago. I said, well, wait a second, man. I mean, this guy is going to, try to debunk Brian. Well, why don't you wait till he comes around? I mean, you're a little late to the party here. So I've done some more digging, and he's the one that is solicited funds. He's the one that it's going to go with the pole-to-pole circumnavigation. I don't know if any of you guys heard about that.
Yeah, heard of that.
Yeah, so he's on that and done a little more digging, and this guy had come up with 11 questions that flat earthers are afraid to answer, right? And I said, I never heard of these questions before. Must have been about a year ago, year and a half. I don't know how long ago it was. And I said, well, I didn't have a chance to get afraid. So I said, well, the heck with it. I'll go chase these down and see if I can't get afraid. So I didn't get afraid, by the way. So I went through these 11 questions, and I put some answers together and wanted to go through them today. Now, we'll go through these. This is going to be relatively quick, and we'll spend a few minutes on a couple other topics. Should be about 15 minutes. So you guys ready?
Ready when you are. Excellent.
All right. Greater Sapien, 11 questions flat earthers are afraid to answer, boy. So special note, each one of my answers has the same scientific veracity as any Globetard answer. Okay? I want you guys to keep this in mind when we're going through here, okay? So question number 1. Where is Venus right now? So my gut response was it's in the sky. I figured I'd roll with that. Seems appropriate. I think it's correct. So now questions 2 through 9 deal exclusively with the sun and the moon. Now, it's my contention that these two celestial bodies are governed by brigades of invisible three-toed gnomes. And I'm serious. All right? The sun camp, or the sun division, and the moon camp, or the moon division. All right? So number 2, why do the sun and moon rise and set the way they do? So my answer is, well, the sun and the moon don't rise or set in any scenario. They only appear to do so. 2A, how does the flat earth model explain this? I knew I was going to get into the models. I just can't get around it with these guys. So let's go over this for the 10,567th time. Models don't or can't explain anything because they don't have sentience, intelligence, the ability to reason. They have no lips, tongue, or vocal cords, or typing skills. See reification fallacy. Additionally, there is no FE model. Why? Well, models are pseudoscience. Please show models in the scientific method and not ball and stick airplane models either, okay? From the physics department at the University of Rochester, the word model is reserved for situations when it is known that the hypothesis has at least limited validity. From Physics About, a model is used for situations when it is known that the hypothesis has a limitation on its validity. Allow me to translate this for you. It's pseudoscience. There is no such animal as a scientific hypothesis with limited validity. It's tantamount to a woman being a little pregnant. Real scientific hypotheses are either confirmed or invalidated. Period. End of story. Furthermore, scientific hypotheses do not exist in perpetuity or wait for more data. Data comes from experiments. Those are hypothesis tests. A model is conjured when the alleged hypothesis is untestable. That means there never was an actual scientific hypothesis to begin with. P.S. By you asking these malformed questions reveals that you'd fail 5th grade general science and an 80 level basic reasoning course. So, number 3, why does daylight on Earth have the pattern it does? My answer? It follows the path that the invisible 3-toed gnomes from the sun camp or sun division carry it on and allow it to have. Listen, this answer right here, or my explanation, is just as scientifically valid as any answer they have.
Yeah.
Number 4, what holds the sun and moon in place and moves them? Answer, well, my invisible 3-toed gnome divisions. Duh. 5, why do you see the same face and phase of the moon no matter where you are on the Earth? My answer, the invisible 3-toed gnomes, these are the moon camp or the moon division, project the same face and phase of the moon to every single person on Earth, no matter the viewer's location. Sounds like a great explanation to me. Fits the observations. Why does a lunar eclipse happen? Number 6, my answer, the invisible 3-toed gnomes from the moon division or the moon camp carry dark matter Superman capes. Every now and again, they unsheath them and cover the moon. It's kind of like a prank. It breaks the monotony of hauling the moon around for millennia. Number 7, how does a solar eclipse happen? My answer, well, the invisible 3-toed gnomes from the sun camp division carry dark matter capes, Superman capes also. Every now and again, they unsheath them and uncover the sun. It's kind of like a prank. Breaks the monotony of hauling the sun around for millennia. 7A, why does the shadow of the solar eclipse cover such a small area? Thanks for that. My answer, because the sun is small. And back at you. According to the heliocentric sun-worshipping spinning ball space monkey religion, the moon purportedly eclipses the sun to cause a solar eclipse. Since incoherent first graders and above know with absolute certainty that an object can't cast a shadow smaller than its own diameter, can you please explain, along with experimental verification there, Professor, why last summer's solar eclipse here in the U.S. had a path of totality shadow 70 miles wide?
Ha ha ha. Good one. Good one. Good one.
When the purported diameter of the moon is 2,159 miles wide. I am just itching to hear the answer to that.
And sorry to interrupt for a slight moment, but also the sun is much, much further away from the moon, so it could never have like the same angular effect, making it that small.
Okay.
So, continue.
Thank you. Number 8. Why do the sun and moon have spherical shapes? My answer, they don't. They have disc shapes. You cannot ascertain depth of celestial bodies. You merely conjure spheres. P.S. Even if they were spheres, it doesn't logically follow that what you're standing on is spherical. See the pool table and the billiard balls. Number 9. What powers the sun? My answer, invisible 3-toed gnomes, that's the sun camp division, flatulence combustion. Okay, back at you. Now, according to the heliocentric sun-worshipping spinning ball space monkey religion, the standard model read pseudoscience of the sun states that it is more or less a nuclear fusion reactor. We went over this the other day. We're going to go over it again. Allegedly, it has an inner core temperature of 15 million Kelvin. So let's take a look at this. This is the depiction of the sun. You have the inner core, right? You have the photosphere, which this is the surface of the sun, which moves out to the chromosphere, and then the corona. Okay, that's how it's depicted in their pseudoscience. Here is the temperature profile of the sun according to the standard pseudoscience. Now, on the y-axis, we have temperature in Kelvin. On the x-axis, we have distance from the surface of the sun. So as you can see, the temperature slowly goes down here to about 5,800 Kelvin in the photosphere. But the problem here is everything after this point. Why? Because the further it's moving away from the source, the higher the temperature's getting, right? And then it goes parabolic between the transition between the chromosphere and the corona. And then it goes parabolic again up here. So does anyone see the problem with that? So the inner core temp of the sun is 15 million Kelvin. The outer surface of the sun, or the photosphere, is 5,800 Kelvin. On its way to and through the chromosphere, the temperature slowly rises, then goes parabolic from 10,000 Kelvin to 500,000 Kelvin when nearing the corona. And then from 1 million Kelvin to 10 million Kelvin.
Interesting. I wondered how they actually measured this.
Well, we're using the
Just
standard
pure theory, maybe.
Well, we're going with the standard pseudoscience model. Let's just roll with that. I suppose you and the fairy tale pseudoscience priests collectively missed the lectures on the second law of thermodynamics. Heat really does flow up parabolic hills. This is tantamount to standing near a wood stove, then moving back 500 meters because it's too hot. Then you spontaneously combust. That's how ridiculous this is. Okay?
It is actually kind of funny because at the same time, according to the same pseudoscience, the Earth has a molten core and it's a lot hotter in the core, basically, and gets less hot to the outside. It's kind of weird that they reversed that concept with the sun.
We're going to talk about a little bit of a facet of that here in a few minutes. So we'll get to that.
Continue.
Okay. Number 10. Why has nobody gone to the other side of the Earth? Answer? What other side? I thought I read the question. I said, this is one of my answers going to be.
That's so silly, man.
I don't know if I'm missing something. I could be, but I don't think I am. Okay, last question. See, we're just rolling right through these. I'm pretty scared still. Number 11. Where is the definitive model of the flat Earth? Okay, I already answered this. I already answered this. Models are demonstrable pseudoscience. So go up that. I put the full answer here again. We don't have to go through it. I already did it up above. Just see that answer above. Okay.
I like your gnome explanation. It's interesting.
Thank you. Appreciate that. I'm pretty committed.
I could think of some more holographic based explanations.
Don't worry. Let's just stay committed to the three.
These are really fun questions. These are questions that by now, like 3 years ago, I would have been like, how do I explain this? But in 3 years, we've been talking so much about this kind of stuff, putting our minds together, everyone figuring out their own thing. I think that these are now doable questions by most of us. We could give elaborate answers to it, each in our own way.
I quite like how you've decided to just, roll with the old pseudoscience, return nonsense. I mean, the bottom line is here, you don't have to come up with nonsense to smash someone else's nonsense. You can just smash it into pieces. Whereas you've revealed your hand and shown your absolute devout faith to the three-toed gnomes, which is wonderful. It's nice to know.
Yes, I'm quite committed. See, I can give you a Just So story to call your Just So story. No problem. I don't have an issue with that. Okay, now, did anyone notice the 11 questions for flat earthers? Special note.
No problem at all. No problem. They don't
special. Yeah, but special note.
And they're almost all heavenly body related too, by the way.
That's what I'm talking about. See, not a single question that we were so afraid of, and I'm quivering in my boots right now still, was directed towards the shape or the curvature of the Earth. Not a single one. Right?
I guess that's what he's afraid of.
This is tantamount to challenging peanut butter and jelly sandwich believers by asking questions about the lights above a sushi bar. Right? I mean, I'm speechless, but I'm also still afraid and still quivering. So let me get my act about me. Oh, I love this. This is my favorite. Can we roll on?
Yeah, go ahead.
All right, this, I'll tell you what. Okay, for the 57,000th time we've reached this, I'm convinced it's that number. No vacuum of space. I'm going to go over this again. Okay, so listen up. This is the question. Okay, how do you have a gas pressure, atmospheric pressure, without a container to begin with? I'm going to repeat this. How do you have a gas pressure that is atmospheric pressure without a container to begin with when the pressure of a gas is the force that the gas exerts on the walls of its container? Okay. Now let's take a look at this. Let's look at some other citations talking about gases and gas pressure. The kinetic molecular theory explanation of Boyle's gas law. Observations about pressure may be explained using the following ideas. The rapid motion and collisions of molecules with the walls of the container causes pressure. Now, as you can see, we have a few conditions here, right? We have rapid motion, collision of molecules, and the walls of the container. If you take away one of those conditions, you take away the cause of pressure or force on a unit area. Pressure is proportional to the number of molecular collisions and the force of the collisions in a particular area. The more collisions of gas molecules with the walls, and what are we talking about here? Well, the walls of the container just above, the higher the pressure. Okay? Check target. Excuse me. A gas is a sample of matter that conforms to the shape of a container in which it is held and acquires a uniform density inside the container, even in the presence of gravity and regardless of the amount of substance in the container. If not confined to a container, gaseous matter, also known as vapor, will disperse into space. It's called increasing entropy. It's the laws of thermodynamics. The next one from sciencelearn.org. The atoms and molecules in gases are much more spread out than in solids or liquids. They vibrate and move freely at high speeds. A gas will fill any container, but if the container is not sealed, the gas will escape. From the University of North Carolina, gases behave differently from the other two commonly studied states of matter, solids and liquids. So we have different methods for treating and understanding how gases behave under certain conditions. Gases, unlike solids and liquids, have neither fixed volume nor shape. They are molded entirely by the container in which they are held. So we have one from NASA. 3 sentences, 3 times they mention container. I don't know why. The molecules are in constant random motion and frequently collide with each other and with the walls of a container. Because the molecules are in motion, a gas will expand to fill the container. Since density is defined to be the mass divided by the volume, density depends directly on the size of the container in which the fixed mass of gas is confined. Now, this is tutoring for children. Gas, it has no shape or size of its own. It takes the shape of its container and occupies the space given to it. Now, if anyone is interested, they also have a special needs and an ADHD tutor that can help explain this to you. Just go to this site right here. Maybe we can give it in the show notes and you can do it. So I've had 7 citations here, 17 sentences, 15 times it mentioned container. Now, what's the Globetard's answer to my question? Well, gas pressure gradients, derp, right? That's what we hear. Every single time, that is the answer to my question.
To interrupt, John, can you just expand on the pressure gradients, derp? Just give us a bit more of a what they would actually say.
Well, because we have gas pressure gradients that means we don't need a container. I suppose that's the derp. It doesn't matter after that. They're not answering the question, right? Because as soon as they invoke gas pressure, well, that's begging the question, because that's what my question is. Where do you get gas pressure first? Right? I'm going to explain it here. Before you can fallaciously appeal to a gas pressure gradient, that's a consequent, you must first answer my question, where you got gas pressure, that's the antecedent, without a container to begin with. Essentially, you must show a tire pressure, a gas pressure, without the friggin' tire, right? So let me introduce you to Ryan. He's 7. Now, what is Ryan doing here? Well, he's creating gas pressure. If you're a globetard from the spinning ball space monkey religion, you must stop Ryan and ask him what in the world he's doing, because you believe that the creation or the existence of air pressure, that is gas pressure, does not require a physical container, right? So now you must rebuke him swiftly and tell him to stop being a reality and a science denier and remove the tire this instant and start over again. Now, for everyone else that can fog a mirror without assistance, before this illustration, you may have been wondering why some of us may lose our patience, and get upset. Or, using the parlance of our time, we get triggered. When explaining at great length topics like this to grown adults that a crayon munching retard can reconcile in a fraction of a second. For crying out loud, Ryan knows that he needs a container for gas pressure to exist. Are there any questions with this? Okay. I didn't think there would be. So let's continue with this. According to the narrative, interstellar space pressure is 10 to the negative 17th torr. Sea level is 760 torr. Don't let torr throw you. It's just a measurement of pressure. Since pressure and concentration are essentially conceptually depicting the same thing, we could drop the units of measure to torr here and treat the problem as a concentration or density issue, right? So 760, this is more precisely annotated or noted as 760 over 1. And the 10 to the negative 17th is more precisely 1 over 100 quadrillion. So it's the part 760 from the whole 1 and the part 1 over the whole 100 quadrillion. So 760 torr, that's sea level, is 760 over 1, or 760 parts in 1, compared to 10 to the negative 17th torr, that's interstellar space. That's 1 over 100 quadrillion. That's 1 part in 100 quadrillion. Therefore, if I had 2 boxes, a sea level box and a vacuum of space box, each having 100 quadrillion cubic centimeters of volume, the sea level box would contain 7.6 sextillion particles, as opposed to the vacuum of space box, which would contain what? 1 particle in the whole box. How's that for an exponential gradient from the Black Lagoon? I mean, this is preposterous. It's almost unimaginable. It is unimaginable, right? And all this without a physical barrier container separating them. We went over this before too. Remember, we said, this is the Earth, right? With 760 torr. All around here, right? Without a container, without a physical barrier separating here, all around here is 20 orders of magnitude lower in pressure or concentration. Not 20 times, 20 orders of magnitude. I mean, this is preposterous. I don't even know what to say to this.
You underestimate the power of gravity, man.
Yeah. Can anybody?
It's so much stronger than they actually think it is.
Can somebody or anybody
Infinitely
please
strong.
define entropy? Rudolf Clausius, Max Planck, Constantine Theodori, Nicholas Carnot, Lord Kelvin, James Clerk Maxwell, Isaac Asimov, Ilya Prigogine, all just collectively turned over in their graves. There aren't words in any language that can adequately encapsulate this colossally epic, preposterously absurd, natural law violating, nonsensical buffoonery. My word. Any questions? Let's
good.
continue here. Let's continue. Wait a second. Let's continue here. This is pretty important. From the textbook of medical biochemistry. Now, folks, you see biochemistry here. Biochemistry falls under physics. Okay? Thus, the diffusion of solute particles takes place down the concentration gradient, that is a pressure gradient with the respect to partial pressure of gases, until uniform concentration is achieved, right? This is until equilibrium is reached. So we have interstellar space at 10 to the negative 17th torr. And remember, the volume of the universe, per their fairy tale, this is unimaginable, 3.58 times 10 to the 80th cubic meters. Therefore, in an open system, and that's what it is, their Earth in their fairy tale, it's an open system, equilibrium must equal 10 to the negative 17th torr. It's an open shut case. Therefore, sea level must be 10 to the negative 17th torr. But sea level on Earth is 760 torr. Therefore, either the fairy tale narrative is false or the laws of entropy are false. That is the second law of thermodynamics. Take your pick. Guess where my money's going? All in. End the story. You live in a fairy tale. So, in conclusion, this is the question. We're going to go back over this. There it is. How do you have gas pressure, atmospheric pressure, without a container to begin with? This right here is not a frigging answer. But what about the gas pressure gradient? La, la, la. Okay? This isn't the answer, right, to this question. So get out of this little incoherent red herring fallacy you guys got parroting going on and answer this question.
I can answer it for you.
By the way,
gravity.
hold on.
Gravity.
Yeah, right.
Gravity is the container.
Gravity doesn't have any effect on entropy whatsoever. By the way.
Oh, it's gravity.
By the way, I have the answer to the gas pressure gradients within a container and will be happier than a duck on a June bug to share it with everyone. However, you must first answer where you got gas pressure without a container first. Then I'll give you the answer to this gas pressure gradient. Until then, we're just begging the question, right? Moreover, as the result of the conclusions above, all space arguments, that's the ISS, satellites, Hubble telescope, all those telescopes out there in fairy tale vacuum of space, space missions, all of them, Moon, Mars, Jupiter, Pluto, doesn't matter, implode into the incoherent oblivion in a nanosecond. Why? See if you can follow this. If I can disprove the medium in which all of these purported entities exist or take place, then I ipso facto destroy every existence claim associated with it, no matter what evidence you provide. Images, stories, your mental acrobatics, it doesn't matter. Much like, check this, since mahi-mahi only exists in saltwater, that's the oceans, that's its medium. If I invalidate or disprove the existence of the ocean, the medium, then I don't need to waste my time with any images, stories, consensus, and mental acrobatics regarding mahi-mahi. Okay? Everyone got that. Everyone understand that. All right, let's finish it up with scientific prediction or scientific predictions and some globe killers. So this has been coming up. We have a basket full and bushelfuls of Mystic Megs. But this is not what we're talking about here, people. A scientific prediction, right? It's a special kind of prediction that forecasts how the independent variable will affect the dependent variable. It's called a scientific hypothesis. This is from Colorado State. Let's see if we can support that. Let's go to Penn State. The scientist applies his or her present knowledge to predict the effect of the independent variable on the dependent variable. The prediction is a statement of the expected results of the experiment based on what? The hypothesis. We have an agreement here. The prediction is often an if and then statement. So, to have a scientific prediction, you must have a viable, number one, independent variable, and number two, dependent variable. In other words, you have to have a viable scientific hypothesis. I think this is pretty clear. This is cut and dry. I won't need to repeat this another 11,500 times. Okay. Now, the counter to your 11 scary questions that I'm still shaking over, these are our top 10 globe killers that no globetard can or will answer coherently or scientifically. Here they are. You cannot provide a non-physical container, right? I want to see you try. That's number one. Number two, scientific evidence of R, that is the radius of the Earth. Number three, beyond Curie temperature magnetism. Number four, the Coriolis effect with a Velcroed atmosphere. Number five, confirmed z-axis curvature from the x-axis perspective. Number six, hijacking perspective, that is portraying it as curvature. That's the apparent size. That's what the online calculator, curve calculator nonsense. Number seven, straight and level flight. Number eight, long distance line of sight with minimal observer height.
Hooray.
Number nine, salt flats, just like, for example, the Salar in Bolivia, with less than 1 meter vertical relief that equals drop over 9,000 square kilometers. And number 10, the Sea Sparrow Block 1. These are the top 10 globe killers. They are the undisputed. You will not be able to answer these coherently or scientifically. Thanks for your ear. Have a nice day.
Awesome, John.
Super.
Pleasure to listen to as always.
Yeah, that was excellent.
It was excellent. Smash those globe heads into the middle of next week.
You want to leave these up so no one misses them? Maybe somebody wants to copy them down or something.
Yeah, I mean, I'll stick them on. They're dedicated to air now, but yeah, top 10 globe killers. Awesome.
Yeah, and these aren't just mine. I put these up to the Supreme Council.
The Supreme Council of Flat Earth.
Yes, yes, sir. And they were approved.
Indeed.
So there you go.
I don't know.
So-
if it were my list, I'd probably put the Sea Sparrow at number one, but that's just
Now,
me.
now, in no particular order, I didn't want to put any emphasis on either of these. I just put them the top 10.
I get it.
They don't have order of importance.
Cool. So yeah,
But
scribble
I
those down,
agree.
screen cap 'em.
This guy, I agree. This guy right here, bye-bye now. You're done for, Glovers.
If you want to know
Okay.
more about the Sea Sparrow, check out Strange World. I think it's number 22 with the missile instructor. I'll dig out a link and I will put a link below this video so you can check out Mark Sargent's interview with that chap and what we're talking about. Pencil line of sight being achieved at 50 kilometers. But anyway, yeah, more of that in Mark Sargent's chat from a couple of years ago. Might even be 3 years ago now. But yeah. Ranty, are you there?
Yes, I am, yep.
So today you went live and did a bit of a presentation which you worked very, very hard on. And
Well,
it's
yeah.
hopefully you're going to present that with us now if you're okay with that.
Yeah, sure. Yeah, essentially I went live this morning. I was doing some work for the debate this evening. I thought he was going live this afternoon, actually. So I was busy working away, and I thought, well, why don't I just show everybody what it is that we actually do behind the scenes. So I'll present in a moment. And
don't want to interrupt, but can you guys hear me?
I can hear you.
We hear you, Chocolate. Thanks for being here. Sorry, I didn't want to interrupt John. I did forget to say hello, so sorry.
No, it's all good. What's going on, guys?
Right, you're
Hi,
up,
Chocolate.
Ranty.
All right.
We're ready when you are.
Right, so essentially this image that I'm showing on screen now is what I put together live on a live stream this morning, and it's something that I would have probably presented and maybe a 5-minute segment of the show, but to actually put this together probably took around about 35-40 minutes to actually get to some kind of answer as to what the angular size was of these turbines and where they would terminate as regards to perspective. So you can check that out, the full video. I do it, I put this composite together, I then put all this writing on, and I work it all out. Essentially, this turbine here, which has a hub height of 246 feet, judging by angular size reduction and following this red line, as I scroll in, I'll show you this red line coming down, and I've put the termination here where it meets the horizon at 22.34 miles. We figured out that using Metabunk's Earth curve calculator, the hidden should be 240 feet at a distance of 22.234 miles, viewer height 7 feet. Curve calculators say 240 feet. Well, what a coincidence that the perspective actually matches up with the hub height of 246 feet.
Wow.
And you know, this was live, this was done today, it was on the fly kind of thing, but I thought I would show everybody how I actually got to this result, how we work it out, how we use Google Earth to determine the position of the turbines, my exact location, which is here with the GPS coordinates. I use video to prove my location and elevation above sea level. And essentially we're working on these turbines here, this row. And as we're looking down this row from this angle, the terminator line would roughly be about here for these particular turbines, because these turbines are smaller in height than these turbines behind the different wind farm. So the terminator line, which would be here, say there to there, would actually be consistent with the curve calculators. Now, you can look at it that either way. You can either say, well, that proves the globe Earth because it's consistent with the globe Earth. But what you've got to factor in then is if I've ran them through the center of the hubs and we've got an exponential drop on the globe model, then that wouldn't work for them. The only way it works and we get a consistent to within 6 feet is if it's on a flat plane. And this is the perspective argument that I don't think people understand. And I'm also going to do a little presentation on the fly here. This is an image that I just brought up on from I'll show you here actually. Wind turbines. So I just put wind turbines in. Just found an image that looked nice, and I'm going to work with this image here. So this is a perspective view of the wind turbines. It's very similar to the ones I've been showing with the lamp posts going down the street. And as you can see in the distance, they get smaller and smaller as they go away. So I'm going to try and replicate that on this here. I put the first turbine in, and every one of these turbines now is 75% reduced. Sorry, 25% reduced. So it's only 75% height of the one previous to this. So I'm going to just stick them in, and I'm going to show you how this actually works out. So we're going to pop that down to here. This is like a live what we work on. So just bear with me whilst I put all these in. But essentially, as you see, in that they're getting smaller as they go away in distance, as exactly as it is shown on these particular ones here. So we get to a point where we're down to a very, very small turbine in the distance. So let's Let's copy that one. And we're going to pop it in here. Right, so there we have the very smallest. It's incredibly hard to see because it is so small because it's gone so far in the distance, right? And now what we're going to do is put a little bit of obstruction in. Now this is only hang on, what size is this image resize? So this is a width of 3000 with 5 pixels in height. Right, that's all it is. It's only 5 pixels in height. So I'm going to select that and I'm going to pop this as the obstruction. Now you can call it, you could say it was a wave, you could say it was the dirty air, or whatever you choose to say. But at some point, they will blend into each other. So let me crop this out now. Where are we? So I'm going to crop that out. Enlarging it so you can see it. Do it by 500. Now you can see that the blade is actually touching this down here. You can actually see that if the blade was turning around, it would be touching the wave or the water or whatever you would choose to see it in the images. So when I show you an image like this, where are we? Like this image here, and I zoom in and we see these in the distance where they are touching the water. We see the blade is touching the water. That's all consistent with perspective. So if I crop this out so you can see it hopefully a little bit larger, and then we'll resize that again.
Yeah, so the white part that you added in is basically the optical slant. It's the sea being reflected up.
Yes, I've put a very, very small layer of dirty air, which I've choose to call it. You could even say it was a 6-inch wave. If there was a 6-inch wave on the water and you're looking over 18 miles, it would block out the bottom of the turbine, just like this.
And would appear to be like it would be the apparent horizon.
Yep, and as the blade is turning around, it would touch the water. So all those people that say that perspective won't allow you to see this in an image is talking rubbish. Absolutely talking rubbish. You can actually see the dirty air along here. You can actually see it.
And just to compare the two photographs, this one that you took, it is very long distance and then basically zoomed in. The other picture was taken pretty close by, right?
Oh yeah, yeah. This
so
one,
it's much closer to the actual objects, so they don't have as much.
This one is probably half a mile away from the turbines. That's probably taken half a mile. This one, I think it was 13 miles to the big ones, and to the ones behind it was about 20 miles away. So the ones that are smaller in the distance are 20 miles away. The big ones in the foreground, 13 miles away. And this is at almost maximum zoom to get these. And obviously, at some point, they will become small enough due to their angular size that they would disappear completely. There would come a point where you couldn't reduce the angular size anymore to just be a pixel. They would just be a pixel on the horizon.
If they wouldn't just be blurred out by the air.
No, I mean, if I go to this last image here, so this is the last one that I put in, and if I was to resize this again by percentage to 75%, again, its width now has gone to 13 pixels and height is 15 pixels. If I reduced it to 50%, 50%, it's now down to 9 pixels and 10 pixels. We're talking pixels here. So just through the angular change, at some point, it would become impossible to even see them.
And considering we see a consistent fold line with usually an inferior mirage below it, and that absolutely does obscure anything of equal height behind it, you can say categorically that you can have perspective obscuring things in the distance exactly as we see them. And because they fall in line with this calculator, sorry, I'll just resize my screen a little bit. Because they fall in line with your measurements that perfectly demonstrate perspective, we can say categorically that they have co-opted perspective and called it curvature.
In the calculator, at least.
Indeed, I mean, it can't be any coincidence that the curve calcs actually match up by putting a line through the center of the hubs in the straight line, and the terminate at the same distance, the same height, everything's consistent. Like you say, they have co-opted angular size reduction for curvature.
Wow.
Thank you very much. That's today's presentation on that.
Absolutely awesome, Ranty. That really, really was cool. This is now my screenshots on screen now, so don't get confused. These are just standard pics from the debates that I'm sticking up, so they're not actually anything to do with Ranty's demonstration, which is now concluded. Thank you very much, Ranty.
No problem.
Cool. I might have our break a little bit early, if that's good by you guys, and then we're going to have a 10-minute break for a coffee and then start the next show in maybe 2 or 3 minutes' time. You guys all good with that?
Yeah.
Yeah, that's fine. Great presentation, Ranty.
Yeah, same goes to you, John. Your presentation was superb, as always, so, without blowing too much smoke up you guys' asses, I'll probably conclude on that note. So with that, I'll say first and foremost, a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully sharing this debate. And of course, a massive thank you to all of the debating panel for making this debate possible. If you hated the show, well, I'm sure you know exactly what to do. But if you like the show, maybe consider sharing it with a friend or subscribing if you have not done so already. I've been Nathan Oakley, and I will see you all in the next video.
Oh, what a day! What a lovely day!